Okay, let's start with this first proof. We're going to talk about the things that are given. And so this is right here, as you can see, there's a proof where nothing is given to us, where we're expected to do the entire amount of work here. Now remember that our proofs are broken down into statements and reasons. So just so we know what I'm doing there. So I've got some stuff that is given, and I've got some stuff that I'm trying to prove. Let's talk about what is given. Which things are given to me? Good. I'm just going to mark that in here because let's not try to remember that. Let's just mark it in here so we can see that. This is true. They're saying this is true. You can bet on that. No worries. You don't have to prove that. What else is true? Okay, M and P are parallel. Those things are given to me. Now, proofs are not easy. They're not just like, oh, I can sit here and I know everything to write here. I don't. I sit here and I go, okay, well, now what is it that they want me to prove? So which angles are the ones that I need to prove are congruent? 1 and 16. So all I'm doing here is I'm just making myself a mark. And what I'm doing is that's the connection I need to make. Now I'm looking at those and I'm just going to go from the beginning. I'm going to go, well, are they like alternate exterior, alternate interior, same side interior, or do they match any of those? If the answer is no, then I'm going to need some steps to do that. Like I can't just jump right to it. It's not a one-step solution. So let's start with our given. So let's start with our very first line that we all know is going to be first. Let's start with A is parallel to B, and M is parallel to P. And we all know our reason. What's our reason? Given. Now, we might all go different directions here, but we need some way to connect those things. So let's make some sort of association that we know. It's got to be like, I know this is true, something. Kayla.
You do angle 1 is congruent to angle 8 because they're alternate exterior angles.
Fantastic. So here's what you're saying. Angle 1 is congruent to angle 8. Now, just so you can see where they're at, now this is not the only way. There are other ways. I'm not going to go through all the ways. We would be here all day. What she is doing is perfectly fine. What she did is not even what I wrote down to do, but I see where it's going and it's perfectly okay. Angle 1 is congruent to angle 8, and that is because the lines are parallel, we can say alternate exterior angles. Yes? I don't want to go different direction. You're going to say like another suggestion because that would be a whole different path. Okay.
But, what if you put angle 1 equals angle 8 after you put that?
Well, when we're talking about this, we should start with them being congruent.
Yeah, after you put that they're congruent, can you put on the next one angle 1 equals angle 8 and then put definition of congruency?
You could, but I don't know that we need it yet. The question is, do we need it? If we need it, sure, we'll write it. But I actually don't think that step is going to be something we need. It's not going to get us any closer to where we're going. You'll see why in a minute. Now, what you're saying, that thing is going to be very relevant at the end. Why? Because notice this is not a congruent sign, it's an equal sign. So what you're saying is definitely important at the end. Okay, so we went from 1 to 8. So we know that 1 and 8 are exactly the same. So the question is, what now? We still need to make a connection between 1 and 16 somehow. Yes, ma'am?
Angle 8 is congruent to angle 16.
Okay, angle 8 is congruent to angle 16. Why?
Because of the corresponding angles.
They are corresponding angles. Okay, now we've got that 1 is congruent to 8 and 8 is congruent to 16, but we still haven't proven that 1 is equal to 16.
If I don't put postulate in the corresponding angles postulate, do I get it wrong?
I would expect at the very least in the beginning that you wrote corresponding angles. Anything less than that would get no points.
Okay, so I don't have to write postulate.
Are you asking me for this quiz? I would say in the future, yes, you have to write postulate. I think post is probably the shortest you'd write. But are you asking me on this next quiz whether I'd mark it off if you left off the word post? Probably not on this one, but on everyone after that, for sure. I mean, this is the first time I'm asking you to take this all the way through.
And what if,
Theorem and postulate, I don't care whether you mix those two up. Those are two that I go, I get it. It's hard to differentiate the two. Let's just give me an idea. But let's keep going. 8 and 16. Yes, sir. Okay, so what do you want to do? What should I write as my next line? is congruent to angle 16. And he said that's what substitution. Notice in the first one, angle 1 was congruent to angle 8, so he's just subbing that in. That's substitution. And so we're done, right? No, we're not done because it didn't say congruent, it said equal. Take it.
Angle 1 equals angle 16 and
Definition of congruency. Now, if you think about it, like you may have known this, you may have not known it, but I didn't do this proof. You guys just did this proof. I'm not even joking. What I wrote down on my paper here to like my little notes that I just did, like when I was like, oh, let me work it through first, it doesn't say this, but that is correct. There are other ways to skin this cat, if you will. Yep.
Would it be wrong if for the fourth one you put transitive property instead of sub?
That would be perfectly fine. This could be transitive or sub. They don't always mean the same, but when two things are equal to the same thing or they're both congruent to the same thing, then you can use transitive to bring it in. Substitution or transitive property would both work in this case. But I always say, and again, this is what got people on the last test, is that sometimes if you're ever torn and you're not sure, go with substitution. It's always a good bet, whereas transitive only works in certain cases.
On this quiz, are we gonna only have to do?
I told you, expect that you're going to have to do everything up there, that you're going to have to do both sides. But I feel like if this made sense to you, then I don't think that the proofs are harder than this. If this was really hard for you, then yeah, I think the proof's going to be really hard for you. I mean, this is probably a good benchmark, this one right here, of like what would they be like? They're probably equal difficulty level to this. Now, obviously not this one, but something close. Slide 2. Now this one is not a proof. It just says, is it possible to prove that the lines P and Q are parallel? If so, state the postulate or theorem you would use. So let's talk about 1. Is it possible to prove that they are parallel? If so, why? So if your hand's up, it's because you know both answers. Yes, sir.
I put yes and because it's same side interior angles converse.
Okay, so we say yes, it is. And the converse of the same side interior angles theorem. Now, again, I don't care whether you put the word converse at the beginning or the end, but understand without the word converse, you just lost 100% of the points because they're totally different things. What if I put postulate instead of theorem? I don't care about that.
Okay, so could you also, for that one, could you also use the alternate interior angles?
Negative, because you don't have any alternate interior angles here. To do that, I would either need to see this up here or I would need to see this down here, which would then prove it. But good thought. Yes, ma'am.
Could you say consecutive interior angles?
You could. It's used very little, though. So I always try to push people away from that. It's not wrong. It's just we're going to see that used much less often than same-side interior angles. All right, let's look at the next one. Tyler.
I put yes.
Yes, because?
Corresponding English.
Okay, so the converse of the corresponding angles postulate. Notice that 70 and 70 are in that same position, that upper left-hand angle, if you will. So this is definitely the converse of the corresponding angles postulate because those two angles are congruent. Talk to me about 3.
I put no
No? So give me a justification as to why.
because there's nothing that
I can 100% prove to you that those are, in fact, guaranteed not parallel. It's not that there's not enough information. I can 100% be 100% sure that those are not parallel. So that's what you're right about no, but not only just no, and here's why.
They don't add up to 180.
What doesn't add up to 180? Because it never said anything about this angle and this angle. The ones that need to add up to 180 are the same side interior angles.
They're not.
So why? So that's what I want. So keep going. So you're saying they're not, but I don't see the same side interior angles. But I think you see something that we're not talking about yet. Like those two angles that we're looking at are not same side interior angles. So I couldn't look at those two and say those two don't equal up to 180, but maybe we can play around with them. Sir?
They're not congruent?
Well, they're not supposed to be congruent either. There's no relationship with those.
Oh.
The angle 115 is corresponding to the top right.
Okay, so this one is corresponding to that one?
Yeah.
Okay. but they would only be the same thing if these lines are parallel. So the only reason that that one up there would be 115 is if they are parallel. Take a look at that 75 for a minute. There's only one thing I can guarantee you, and it deals with that 75. It has to do with the 75. Alexa.
The vertical angle.
Okay, perfect. Vertical angles will always work, whether the lines are parallel or not. So who cares? That's you're right, by the way. But who cares? So I got a 75 there. What did that just show me? That is 100% the direction you need to go. Got anything, Alexa, about those? It was your idea, so I thought I'd let you go with it.
Interior angles, same side interior angles are supplementary.
Are they?
Well, that's what the postulate says.
The postulate says they should be supplementary. Are they?
They're not.
They are not. When they are supplementary, the lines are parallel. These are not. 75 and 115 is 190, not 180. So this is a guarantee that they are not. There's no doubt in my mind. Not always can I prove it or disprove it, but this one, I'm 100% sure they are not parallel.
Okay, on test quiz, if we have that, would you have to like explain why?
It would probably say no, explain why. But sometimes there could be just not enough info, but this is not, this question is not a not enough info question. There's definitely enough info to say these are not parallel.
How would we say it?
This isn't a proof, so you could say that, you could do this. I could just explain it like this. That's vertical angles. Let's say this was a question, not supplementary.
And just like that.
That's enough. It just said explain. That makes sense to me. Like right there, I see. How did you get that 75? Vertical angle theorem. How did you know why were you making a connection? They were not supplementary, therefore they're not parallel. That's really, in terms of, this is not a proof, so I don't need all that explanation, but I'm just showing you this clearly. You can see my line of thinking, what happened. How did I know they weren't parallel? Let's talk about 4. Daniel.
Alternate exterior angles converse.
Perfect. So these two things, whatever they are, I don't know what they are, but they're the exact same thing. And the truth is that when the alternate exterior angles are congruent, that means the lines are parallel. Therefore, yes, because of the converse of the alternate exterior angles theorem. How about 5? You're prepared to back it up either way, right? Okay, go.
I think yes, because of vertical angles.
Is vertical angles a way to prove that things are parallel?
Oh wait.
Was that on our list of things? That was not. I'm not saying you're not wrong. You're not wrong that that's vertical angles. That is definitely vertical angles. But that is not a way to prove that things are parallel. There's definitely not enough info here. So here's what I know. I know that these two equal 180 together, and these two equal 180 together. And even if I went like this, and I go, okay, but that didn't help me with anything. Like, I still don't see alternate exterior angles. I don't see alternate interior angles. I don't see alternate exterior, alternate interior. I don't see corresponding angles. I don't see same side interior angles. There's just not enough info. So no, not enough info. I shouldn't even say no, there's just not enough info. Like, I can't say, the question asks whether I could state that they were parallel. No, I can't. It's not that they're not. They may be. I don't know. There's just not enough info to say. Maybe, maybe not. Not sure, not enough info. Because all of those things that I was looking for to prove, they're not there.
So if we have a question like that, we could just put not enough info.
Not enough info.
If you put no, would it be wrong?
If it said explain and you just wrote no, then that's not an explanation. All right, number 6. Yes, ma'am?
Yes.
Because?
Because the corresponding angles converse.
Okay. Corresponding angles postulate, and it's the converse because we're trying to prove that two lines are parallel. I'll tell you what's going to happen. A lot of people are going to lose a lot of points on this because they're not writing the word converse when we're trying to prove two lines parallel. I'm going to tell you, somebody's going to be like upset after this because they're going to say, I would have gotten an A if I had just written converse. I don't want that to be you, and I'm not saying that as a joke and like, haha, I'm saying that as like, please don't let that be you. I don't want that to be you. but I'd rather point it out to you because I see that every single year, and it's the number one thing that people go, well, wait, when do I use, I didn't understand when to use converse, and I'll be like, well, that's what we talked about the whole time. When you're trying to prove that two lines are parallel, that's when we use the converse.
The two that I do, the two I get.
That's okay. Listen, I appreciate that you tried. All right, so let's try some others here. Now, these are the harder ones there. So we're going to try to make connections and understand that there are multiple different ways. Just like if I said right now, let's go meet at Sawgrass, we might take it different routes there. We might do different things. It might take us different amount of time. Some of you might stop for coffee on the way. Some of you might rush right there. It all could be different. But as long as the only things we should be writing are the things that are needed to say what we need to. Like if we didn't need it, we shouldn't write it. And then every single thing that we do, if we are doing it, if we are doing some math or making some changes, for those of you who are playing games right now, then those are the things that we need to write. So what I'm going to do is I'm going to do my statements and my reasons. Now let's just do this together. You know what I mean? It's like, when I approach these, I don't approach these with an answer key because I hate the fact that a teacher would approach this with an answer key and go, yeah, this totally makes sense. That's not how you get to approach it. You don't get to the answer key and go, oh, that makes complete sense. So let's go with what we know. Angle 1 and angle 6 are supplementary. So I'm just going to write that down as my given because I want to get credit for those points. Angle 1 and angle 6. Notice I didn't put plus, are supplementary. And that was given. Now, what I'm trying to prove here, just to be clear, is that this line here is parallel to that one right there. So here's what we're going to need for that to happen. For that to happen, we are going to need to know that there is a pair of alternate exterior angles that are congruent, a pair of alternate interior angles that are congruent, a pair of corresponding angles that are congruent, or we're going to need those same side interior angles to be supplementary. So that should be our goal as to where we're trying to get here. To be able to prove this as our last line, we need one of those things to happen. Nathaniel? I think that's a good place to start. Let's try that. He said 1 is congruent to 4. Now we're going to try it. For all I know, we may end up erasing everything, but this is certainly a start. Angle 1 is congruent to angle 4. If it makes you feel to get better, this was exactly my second step as well. What is the reason for that? Vertical angle what? Vertical angles theorem. I would not mark off for postulate, but just understand it's the vertical angles theorem, VAT. If you wrote definition of vertical angles, you would not get credit for that. That is not the definition of vertical angles. The definition of vertical angles say that when you have two opposite rays and they share a non-common side, then the two on opposite sides are vertical angles there. Two pairs of opposite rays. That's what we're looking for. So vertical angles theorem, not definition of vertical angles. All right, so we've got 1 and 4. Now remember the things that we're trying for. To prove those lines, though, we need some sort of connection. Now, there is something about 1 and 6, so if we can make that combination, great. Yes, sir?
I got angle 4 is congruent to angle 6.
Angle 4 is congruent to angle 6. I would disagree with that. Why would I disagree with that? They're supplementary. Now, it's possible that they are congruent, but it never said that they were. There's only actually one situation in the world where they will be congruent. Almost all the situations say they're probably not. But there is one situation where it's possible. It's not probable, it's possible. So where do we want to go next?
Angle 4 plus angle 6 equals 180.
Okay, so I like the thought. I actually don't disagree with you, but I'm going to kind of change this a little bit. She's saying angle 4 plus angle 6 equals 180. Okay, actually, yeah, we can do that. Yeah, I'm okay with that. That's because the lines are parallel. So yeah, actually, I'm okay with that. Angle 4 plus angle 6 is equal to 180. Angle 4, let me just see. Angle 4 plus angle 6 is equal to 180. Actually, you know what? I'm just not there yet. Because how do I know that they're equal to 180? Like, I would need something else first. But actually, that was very close to what I said as my next line.
Angle A plus angle B is equal to 180 degrees. And then you could say,
Angle A plus angle B?
like, you're just giving like an example, like that equals 180. So the definition of supplementary.
I'm only confused because I don't know where angle A is up there. Where I see a line A and line B. Like none of the angles are marked with letters there. Kayla, what do you got?
Angle 4 is congruent to angle 8.
Angle 4 is congruent to angle 8. Okay, we could do that too. So let me ask you, because I didn't go that direction, where are you going to go from there? Because she's not wrong. She's saying that these two are, my question is that, oh, wait a minute, I think I see where you're going there. I think I see where you're going. Okay.
Can you do angle 6 and angle 2?
No, actually, I'm 100% okay with where Kayla's going. It's actually totally, I hope I know where you're going, because actually where you're going is a very intelligent move right here. So I'm going to go with what she said. So why is it that angle 4 is congruent to angle 8?
Because they're corresponding angles.
Okay, so the corresponding, I see where she's going now. It took me a minute because this is like far from the direction I went, but actually I almost like her way better than mine. Corresponding angles postulate. Okay, so 4 and 8 are the same. So let me just take a minute here because I know where she's going, and I'm going to remove this 6 for a minute. Hi.
Tomorrow, if they don't tell you that it's a corresponding angles postulate, what they tell you it's a corresponding angles theorem.
For me, I said I don't really care about the word postulate or theorem, but use one of them. I'm not debating that too much. So they know that they have to put something there, but theorem and postulate, I realize it's hard to keep those separated.
Yeah, just check.
So Kayla made the connection. Well, first we made the connection between 1 and 4 because they're vertical angles. Now she noticed. She said, well. Actually, no, I'm sorry. I can't do that. I marked that they are parallel. In there, and that's what we're trying to prove. So actually, I really liked where you're going, and I'm sorry I bought into it without even checking my own work, that I cannot say that 4 and 8 are congruent because I don't know that those lines are parallel yet. I can only do that if they are. I really liked where you were going, and boy, if they had been parallel, I loved your way, and I was like, I just realized we can't do that because we can't say 4 and 8 are congruent yet. Yes, sir.
Angle 5 is congruent to angle 8.
Okay, so angle 5 is congruent to angle 8. Let me ask you, where are you going with this? Because I'm worried that you're going down the same road that so let's say when we do angle 5, it's congruent to angle 8. Where are you going to go after that?
Then 1 is congruent to angle 8.
Well, why? What connection? How could you make that connection?
Because they're alternate.
The only way that that 1 and 8 as alternate exterior angles will be congruent is if the lines are parallel, and that's what we're trying to prove. I'm trying to prove that, so I can't use that as one of the things. Like, I can't say because they're parallel. I'll be like, no, that's what you're doing. You're trying to prove it to me. Yes, ma'am.
Angle 4 and angle 6 are supplementary because they are same side interior angles.
Okay, but not all same side interior angles are supplementary. Let me give you this first step, and I think it's going to set us on the right road. So let me go back to this for a minute because we haven't really talked about this. What am I about to do with that? I'm about to do something with that first line. I'm going to take that line and do something with it. They're saying angle 1 and angle 6 are supplementary. I'm about to change that into something else.
Angle 4 and angle 6
Actually, it's just another way of rewriting the very first line. Yes, ma'am?
angle 1 plus angle 6 equals 180.
Good. Angle 1 plus angle 6 is equal to 180 degrees. Now we know that because they're supplementary. I feel like I should use that given, so this is the direction I went. And what is going to be my reason for that?
Definition of supplementary.
Beautiful. Definition of supplementary. Okay, now here's what we've got. We have some information going on here. Like, we have got something going on here. We have got that angle 1 plus angle 6 equals 180. Now, our goal a minute ago is, you guys keep saying this, is you keep going for this, and I'm not against you. I am 100% for you. Your goal is to try to get to the statement that angle 4 plus angle 6 equals 180. And if you're not catching on to how close we are now, we are so extremely close. We are so close to proving that these two things add up to 180. Yes, sir?
6 would be congruent to 7 because they're vertical?
Yes, but that's going to take us actually further away. We're so close to the answer. It's going to take us further away. Yes, sir.
Wouldn't it be angle 4 plus angle 6 is equal to 180?
Yes, pause 1 minute. Pause 1 minute. Yes, angle 4 plus angle 6 is equal to 180. I know that he knows why, but take a look at what he just did there. What did he do? He did substitution. He pulled out the 1 and put in the 4 that we established on that second line. That's substitution.
Finally got something right.
Okay, now I'm going to do something. Now remember, we have established that 4 and 6 equal 180 degrees. However, to prove that A and B are parallel, I need to be able to make the statement that 4 and 6 are supplementary. That angle 4 and angle 6 are supplementary. I'm going to give you like real close. This is how close we are. Like just to give you an idea of how close we are. Something goes here. And then I'm going to say A is parallel to B. I'm going to put in also something there. But that's how close we are. We're that close. But I need to be able to say that angle 4 and angle 6 are supplementary. Try it. Who cares?
I forgot.
How about this? Angle 4 and angle 6, this is what I need to say, are supplementary. Why? Why are they supplementary? Cindy?
Same side interior.
But, I mean, a lot of same-side interior angles, there's such thing as same-side interior angles that aren't supplementary. Yes, ma'am?
Definition of supplementary.
Beautiful. Look at the line above. We've got, by the definition, if the two angles add up to 180, that is the definition of supplementary. This is one of the ones that I think is the harder one. This is certainly a hard one. We're doing the hard stuff now. What you are doing now is probably equally as hard as the ones you'll be doing in the fourth quarter, just with different theorems. Now, I'm telling you, you're only one line away. These things are definitely parallel. Why?
Wait, I have a question. So what I was looking for is because, like, I forgot what it's called, but, like, the thing that says, like, for example, if 1 is parallel to 4 and 4 is parallel to 6 and, like, 1 is... Wait, no. Yeah. Then 1 is parallel to 6. Like, if 1 is...
Are you saying congruent? Like, you're saying parallel. Do you mean congruent?
Yeah, I meant congruent, my bad.
If 1 is congruent to 4 and 4 is congruent to 6, I know what you're trying to say, but you're saying the wrong thing. You're not saying the congruent one. I think you're talking about the supplements theorem, the congruent supplements theorem, but that doesn't work here because if they're both congruent to the same thing here, so in this case, they are supplements. That 4 and 6 are supplements. That's true. But that doesn't show that things are parallel here. That just showed that two things were congruent to each other.
Is it because the contours same side angle postulate?
Of the same side interior angles theorem. So again, would I mark you off? No, bro. If you got all that and you said postulate at the end, I'm proud of you. Like, that's a lot of work there. Like, it really was. But we had to explore a lot of different avenues, and I like that we were just throwing out things. And here's the thing is sometimes you just got to throw something out there and say, well, where does this road take me? Where am I going with this? How is it like, what do I need to be able to prove this? I'm recording this, by the way. I'm going to upload it. So those of you, like, don't worry, it's going on YouTube right after this. Okay, I'm going to sneak one more in. You know what? I want to go exactly to the last one. Go to the last one. I like this one. Do I like this one better? No, I'll tell you what. Let's stop there for this because what I want you to work on for the last 10 minutes that we have, or 5 minutes, whatever it is, are those other 3 reviews that we've got. So take that last time to go over those 3 reviews because you have answers there that you can go over, and we don't have time to go over them in class tomorrow. So if you have any questions, you can ask those today.